Hi to everyone. Today I would like to represent my very recent development for MT-AMT control source, MT processing. It's absolutely independent model and it involved in MT2D software. And currently it's can handle just two types of files. It's controlled source files from Phoenix and EDI created by EPKit software. What is the difference of this processing model? It's called here AK-Corrector from existing model for data processing. This model allows to process all stacks collected on measurement points, and sometimes it's very important because most instruments has a software for processing, and after time series processing you can see only one impedance per frequency, not all stacks measured and processed. This is sometimes bad. If data quality quite good, don't worry about it. Any stacking algorithm will do this work for stacking good. But in case of not, because I am not trust to this median or another stacking approach, this does not involve in processing all curve for impedance, and it's separate processing for frequency or maybe window frequencies. So it doesn't not use this integral of connection between amplitude and phase. Doesn't take in account if you have a several station per line, all neighbor station. So this is why I developed this model for processing such data. So it's has the same buttons for importing data inside, and I'll start to show you this natural source example. I have a free station to make this video simple. I do not use more. Free is enough to show all processing stuff. Now I just load it. As you see here, after loading, I see one component. It's XY component, but actually you can choose every component plus effective impedance, like it's Berdichevsky impedance component, and process it. You can process it all station together with 2D processing or all separately. And of course, all these stacks you can see shows data quality very good, but sometimes you can see that it's very wide cloud of points for left and right. And so to improve our processing, we should remove it. For removing, we use this instrument, and radius of the circle can be changed by mouse wheel. So I can select points or deselect it back. And these selected points will not involved in processing. So very simple step, we just remove, select some noisy point and do 1D processing for station. This the next speech, I'll call this a smooth curve spline. It doesn't mean it's spline, it's just a term. It's used and intended by developers of this technology, Northwest Chair Physics. And software interface very similar and functional, very similar to MT-Corrector software developed by Northwest Chair Physics, but they have quite different mathematics here and algorithm for processing, for building these curves. First of all, we do not build this spline just for one curve, for example, for apparent resistivity or for phase, and recalculate by dispersion relationship another curve. We do it both, so we build operator and we solve approximation problem here. Also, we can do it in 2D if on the station, on the line, we have a several station. It's possible to build 2D operator and solves for smooth distribution along this line. So it's for very noisy data, it's quite important because all data will involved in one approximation. And of course, if again data very noisy, we can have a good first approximation for next denoising and processing. So we can move by these buttons, all keyboard buttons are the same, and do processing. Here we can, of course, change our selection of point. And I would say that all these selection point and all these splines can be kept in one project, and you can return to it whenever you want, because I understand there is can be a lot of station and it's a lot of work, so people need to have a break and get back to work again. So I can switch to another component. For example, this is X, Y, and Y, X. I show it here as amplitude and phase, but additional components plus tipper will shown as real and imaginary part of signal. So it's processed a little differently. The same like basic components, effective components will be also shown as apparent resistivity and phase. So in 1D processing mode, I can process all station I need, and smoothness of these splines controlled by this trackball. You can choose it to get more features on curve or to get more smooth curve in case of noisy data. Okay, also here simple operation for data handling, and here is we can add some values to phase if it's in different quadrant, or we can flip phase for current stage. Also, if some connection to channels mixed up, we can exchange X and Y components. And also this option on main bar, it's controlled source. It's controlled data errors in approximation process. So if we choose small values for phase, it's trying to approximate phases better. If we choose small values for apparent resistivity, of course, in logarithms, it's trying to do best for apparent resistivity. If this option is disabled, it's use internal data errors from file. But from my opinion, better to use this error because we has a lot of realization. For this example, we have a 20 realization, approximately 20 realization per frequency. There is also some selection options for mainly for deselection of selected points for first graph, second graph, for both graphs, or for all components, X, Y, X, steeper, and others. Oh, also here is an option can be used for coupled selection. So if I select, for example, apparent resistivity, phases also will be selected or deselected. So it's joint operation. Again, these options controlled processing of spline. This is smoothness of spline, and this is how a good apparent resistivity of phase should fit to measured data. Also, here is additional options. For example, for 1D processing, it's only smooth error gates, the same for 2D. That's mean that generated error gates after processing will be smooth. It's very good for inversion. It doesn't mean that it's really correct, but for inversion, it's much better. And for 2D inversion, there is additional options. First of all, this is how we handle static shift. By default, it's no correction of static shift effect, galvanic static shift effect, but we can apply three ways. It could be do correction during approximation, and we can apply only corrections. So no splines will be built, but only static shift correction will be applied. So this last option is very fast for all 2D processing, and it can be used, but carefully. So I should say that it's also possible to make static shift correction by this mode. We can move. But if we do static shift correction, it's much better to see previous and next curve on the line. And then we can move it more correct to correlation zone between these curves. Okay. I'll try to do 2D processing for one mode. For example, it will be XY mode. Here we can have no processing, but I can remove some really noisy data. And no static shift correction. Progress of 2D processing you can see here in this status bar, and it contains two-step first core calculation for all 2D profile, 2D line, and after that optimization of operator. But of course here is only 3 stations, and if you have 10, 20 stations, the process can be much longer, much time consuming, because here is about 5,000 points should be optimized during this process, and it's not really fast. So this is 2D processing, and we can see some features here. I don't like it really much. Of course, 1D is much faster, so we can try to make this part of the curve more smooth, or if we don't need this feature, this extremo, we can do it this way. So this is actually, I already said that these two curves is connected. One point for phase represent integral of this curve. So it's based on relationship of first kind. And for real and image part of signal for second kind. So now I can select for processing another components. For example, it's will be additional component. So here you can see real and image part of signal, and we have a different representation of signal. At the same processing stuff. Of course, here is no static shift connect correction. We don't need it for additional components. And this is how 1D, because data error gates calculated in linear scale, but we have here logarithmic. This looks, and this error gates looks a little weird, but in linear scale it will be much better, so don't worry about so big gates. It's really not so big. Okay, so we can also apply to the this is actually automatic processing is quite good, even you not select noisy data. Let's give a very good approximation, so you need just a small correction. But sometimes, in some cases, for example here, because we have a two part of signal with different sign, it's maybe a problem of errors of noise. It's sometimes not easy to understand which one should be chosen. For example, I can, let's see how previous next station looks like. So I can remove it. I'm trying to approximate, but I know that signals should go here, actually. So let's try to approximate this part. But I think it should be another sign. And I'll remove this part of signal. So now I have a good approximation. Okay, get back to, for example, effective component. Another options, because sometimes it's really important to keep scale. It can be fixed here, or you can set your min-max range for scale and not use automatic mode. Or it can be simple, did this option, simply. So now it's not changing when we select another, choose another station. For phases, we have another options with different scale. So auto will choose axis range automatically. Plus we can use range from 0 to 90 degree, or we can use this range. It's very popular now because it's a manufacturer shows this because phase data looks nice in this scale, but it's really not sometimes. So they can apply this axis and scales. Okay, so I think we spoke about all functions here. So of course, as usual in Zolt, you can set some graphical parameters for every curve and for every axis. But we will back to import export tab because here we have a additional options for data export. First of all, this is a frequency range for this data set, plus this is unical frequencies number. For exporting data, we can change this range, and all our generated files will be in this range. But I don't need it actually, and I'll show options. Here is several options for data exporting. First, this is zoned MDF files. It can be read by 1D and 2D software. Also, you can save all components to ED files, all processed components to ED files, of course. And also you can save only effective component to MDF file for 1D processing, because effective impedance is recommended for 1D processing. And also this last options, project MTB. If you're going to save all your work results with selection and splines, you should use this format. And when you load this format, you can see all what you processed before. For example, it's right here. I have a processed project. And here all components. All error gates, all selection, all saved to this file. So this is all, and thank you for your attention. Bye-bye.